Okay, so one of the natural questions people ask is, why make Nuro using this very different way compared to the normal wallets of the past? Why do we need to reinvent the wheel this way? And to demonstrate this, I'm going to show you the performance of the main two other types of wallets out there. And to begin with, we're going to go with the reference wallet. So this is the one that people run on their PCs, and it stores a copy of the blockchain and lets you do everything you normally do. So I'm going to launch actually a slightly different one that I haven't opened probably for too long, just to see if we can actually show it taking a little while. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so that took 17 seconds to launch. This is BitShares PDS ProtoShares, which is a currency launched about 6 months ago, and I haven't opened the wallet for a day. So when I launched the wallet, notice several things happened. So first, it had to reread the blockchain, load it partially, and scan it to see if it's corrupt. Then it has to sync up to the latest version of the chain. And this is the part that's normally called the node part. So it manages the blockchain and communicates with the rest of the network. The wallet part is actually this. So the wallet part is just your address, and there's an underlying private key behind it. Now, if you've been following the Bitcoin Core's development, you would know that Gavin Andresen is actually in the middle of separating the node from the wallet part of the Bitcoin Core, right? And the reason being is that the wallet is a very lightweight part, whereas the node is this heavy part that has to process the blockchain. In the case of Bitcoin, it's about 20 gigabytes now. And in the case of BitShares, it's a lot less. It's about a few hundred megabytes. But it is still far greater than what a mobile device can handle. So that's that. So that took about 20 seconds to launch. And if you don't launch it more than once a day, if you wait like a week, that time that it takes for it to sync up is dramatically increased. So that's a standard blockchain-based wallet. And now I'm going to show you what is known as an SPV wallet. This is a lightweight wallet which just doesn't store a copy of the blockchain, but instead loads what they call headers, block headers, and does some verification based on that. So the most famous instance of this technology is called Electrum. So let's count this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so as you can see, it took about the same amount of time as the heavyweight wallet, and the reason being that Electrum still has to load and verify all the headers from the server. And I can show you it's currently connected to electrum.thw.org. The main advantage of an SPV based solution is that it doesn't have to store this massive blockchain. In the case of Bitcoin, it's 20 gigabytes, and this is a big advantage. And this is what allows solutions like Electrum to be used on a mobile phone for storage reasons. But as you notice, you still got to wait 20 seconds for it to start up, right? And this is not good because you have to understand that most users are coming from an internet banking background, right? You're trying to introduce this technology and you're trying to convince the general public, average Joe, that they should be switching to Bitcoin technology, cryptocurrency technology, instead from internet banking. And then you tell them they got to wait, 20 seconds for it to log in. I mean, it's not a good sell, right? So a solution was needed, right? And the other problem with all this verification is that for a mobile phone, it's not just the time, it's the battery. So you're killing the battery of the phone, doing a lot of these wasteful network traffic. So the third solution, which we call the next generation solutions, is basically a system where the node is in the cloud, and the client just does the wallet functions, which is management of the private keys, signing of transactions. And we believe that is a way we are all going to move towards in the future in order to get mass adoption from normal average Joe people who are switching from internet banking. And this philosophy is everywhere when it comes in the design of Nuro. Everything we are doing in Nuro is to do with making it work like internet banking. So I'm going to just restart my wallet here, and we're going to count how long it takes. So 1, 2, 3, 4, 5. 5 seconds. And it should be noticed that 3 of those seconds are actually part of this Intel XDK splash screen, which is just part of some development thing. So literally it took like 2 seconds to launch, and I'll type in my, some sample data for that to log in. And the login takes literally like a second, and after that, I can, in this case, it takes a few more seconds to load the balance of the account. Again, very, very little waiting, and if I want to refresh it, it's just like very fast. And straight away I can receive funds. I can send requests via SMS and email to get those to get people to pay me very easily. And this is quite rare in internet banking apps. Very rare do you actually have a feature that where you send people your account numbers so they can pay you. But this is like very basic, right? You want something that's very easy and very simple to use. And finally, we have these functions to scan barcodes and put an amount, and then we can just send the funds. So high performance is crucially important. If you want your technology to be adopted by someone that's using a pre-existing technology, in this case internet banking, net banking, mobile banking, then you have to deliver something better. You need to deliver something better than what they had before. In terms of user experience, not just in terms of things like security, because the average user doesn't understand those things, and you can't just tell them to go and read the Bitcoin white paper and to learn all about cryptography. They just want to know that this solution is better than the one they were using before, and then they'll adopt it. And I really believe that Nuro is working very fast towards that direction and getting to the stage where people can adopt this technology, cryptocurrency technology, in place of internet banking. So if we look at the implementation here, in the last videos we went through how we generated the private keys from the username, the password, and the PIN code. And the translation of this for the average user is that we're creating an account, right? You don't tell the user, I'm creating you a private key. What's that? No, we are creating them an account. And the account is identified by their username, password, and PIN code. And when they log into this account, which they can do from any device, because as we have discussed in part 2, the private key and address is generated only from these 3 things. There's no need to store it anywhere. And there's nothing to lose. There's nothing for people to hack. As long as your password, username, and PIN, the combination of those 3 are secure, you're good. Yes, and it does say here that you can't recover it, If you lose it, you will lose your funds. And I think there are disadvantages to this, but there's also an advantage. The advantage is that teaches people that their user and password are very important things. And I think this is still quite lacking in the education side of internet security, because you see these internet servers get hacked, and when they have a list of these passwords and usernames they're selling, by these crackers, you often see just really notoriously bad passwords, things like honey and metric. So we really need to start developing a better culture for people in terms of how to protect their password and usernames. And for Nuro, that's on the first page straight away. You have to protect user and password. You have to protect your PIN code. If somebody gets it, they can access your funds. And this applies to internet banking as well, right? If somebody knows your user and password, they can hack into your bank account, and by the time you find out, they already got your money anyway. Yeah, so there's no difference. So once we log in, when we click login, that's step 2 when we create the actual public key and the private key, and we generate the address. And the address is shown here. And there's your QR code, and you can send that to people to pay. So that's your you receive address. And if we look at the balance, this is the part where we send the address to block cipher to get the balance, and the available funds are worked out based on what's pending. When we click refresh, this is when we load 2 copies of the ledger. So we load one from the Block Explorer and we load one from Block Cipher, and we actually compare them to make sure they're in sync. Then we actually list the transactions. Unfortunately, there's none here, but normally you see a table of transactions. And when you send, you just type in the recipient, which you can get from the QR code, or you can paste it in from the email they sent you through the same app, right, or the SMS. You type in an amount, you put in your PIN code again, and then you hit send. And I have an invalid address, and then you hit send, and that just happens like that straight away, 1 second, and right after you send it, your recipient will be able to see it in the pending funds here straight away, like literally 1 or 2 seconds later, right? And then after a few minutes, once it gets confirmed on the block, it becomes a confirmed transaction, and they can start spending that. Now compare this to traditional banking, where you have, yes, sometimes you do get to the pending stage very quickly, but it all depends on the 2 banks involved. There's no standard. It's a lot of hocus pocus, and also you normally have to wait at least till the next day for the other party to receive the funds if they're on a different bank, and sometimes you get held up for like 3 days or whatever. But in cryptocurrency technology, and with systems like Nuro, which have a 3-minute block time, it's much quicker, and as we've shown, the application of technology can be made very simple, and it can be made in a way which gives the impression to the user, and actually realistically allows the user to just think of it just like another internet banking system. It is just like another bank, right? So except that underneath it, we have all this amazing technology that makes it more secure, makes it safer, makes it faster, and makes it trustless. And that is the essence of applying technology to solve real problems, is that you deliver the same user experience, or a better user experience than before, while underneath you fix the fundamental issues which the user doesn't see and also cannot be expected to understand. Thank you.